A study out of MIT tracked 300 real-world enterprise AI projects, and the results were staggering. 95% of them failed to produce any measurable impact on the company's bottom line. The failure rate had nothing to do with the AI models themselves. In controlled demonstrations, the technology performed exactly as promised. The breakdown happened during the deployment phase, the moment these companies tried to integrate raw AI models into their existing day-to-day operations. Purchasing an AI model does not automatically upgrade a business. Instead, it often exposes a massive gap in a company's ability to actually implement the technology they just bought. Corporate enterprises often resemble a grandmother buying a brand new smartphone. They want the end result, but they lack the foundational technical literacy to set it up, leaving them holding a powerful tool they cannot force to connect. AI companies win the market by executing the tedious, unglamorous implementation work themselves, rather than simply selling a license and hoping the software works. This implementation gap has created a vacuum in the industry, leading to the rise of a highly specialized engineering role. Solving this deployment failure point has become the most critical and lucrative challenge in the tech sector today. Frontier labs build their models in frictionless, perfectly optimized computing environments. Corporate enterprises operate in a very different reality. Most enterprise data pipelines are a chaotic web of legacy databases, held together by outdated code, protected by strict security teams. Many of these environments are completely offline. These air-gapped networks are standard on factory floors or inside government facilities. Taking a model that relies on massive cloud infrastructure and making it function securely inside a restricted, offline bunker is an intense technical puzzle. Real-world AI deployment requires adapting cutting-edge code to survive in hostile, antiquated IT environments. This is the domain of the forward-deployed engineer. Palantir invented the role over a decade ago, and now industry giants like OpenAI and Anthropic are aggressively building out their own FDE teams. They differ from traditional tech consultants, who typically provide a slide deck of recommendations and then leave the project. They are also distinct from solutions architects, who usually build proof-of-concept demos using fake data in sterile sandboxes. An FDE travels to the client's physical location, untangles their legacy systems, and writes production-grade code directly on their hardware until the product works. The FDE acts as an embedded operative, bridging the gap between lab-perfect models and real-world corporate chaos. This chart shows estimated total compensation. It scales incredibly fast, with mid-level engineers earning $350,000 and principal engineers clearing over $1 million. However, a significant portion of this pay is locked in private company equity, wealth that remains speculative until the company goes public. The day-to-day reality involves heavy travel, long hours, and sink-or-swim deployments, where you often operate without mentorship. These salaries function as hazard pay for enduring the high-stress, ambiguous client environments that traditional software engineers avoid. Success in this role requires a T-shaped profile, extreme technical depth, combined with a broad range of soft skills. On the technical side, you must write robust Python and TypeScript, navigate cloud platforms, and build quality checks to verify a model's accuracy. You also need the radical customer empathy and business logic required to tell a client when their requests make no structural sense. This combination is notoriously rare. Most traditional coders lack the people skills for this level of ambiguity, and most client-facing roles lack the ability to write production-grade code. The AI revolution depends on this rare breed of hybrid engineer willing to step into the trenches of legacy IT to make the technology function.